Good morning, guys. Today we're going to be starting chapter 4, which is all about radicals and powers. A radical is anything that includes a root sign, so for example, a square root or a cubed root, and then a power is anything that includes an exponent. So that's what this chapter is going to be about. We'll start today with lesson 4.2, irrational numbers. So an irrational number is any number that is non-repeating and non-terminating. So non-repeating mean that it doesn't repeat. So for example, 2.33333 repeating would not be an irrational number. It cannot be repeating. And non-terminating. Non-terminating means that the number does not end. So a common example of an irrational number is pi. 3.14 and on and on and on. That number goes on forever, so it is non-terminating and it doesn't repeat. Okay. So we're going to start by talking about all the different types of numbers that there are. The first type of number is a natural number. And a natural number is any number above 1. So it would be like 1, 2, 3, and onwards. Okay, so that's your natural numbers. The next type of number is a whole number. And a whole number is anything above 0, including 0. So 0, 1, 2, 3, and onwards. So all natural numbers are also whole numbers. The only difference between these categories is that natural numbers don't include 0 and whole numbers do. The next type of number is an integer. And an integer includes both positive and negative numbers. So now we're getting to numbers that are below 0. So for example, -3 and -2 and -1 and 0 and 1 and 2 and 3. And so on in both directions. So once again, all natural numbers are also integers. All whole numbers are also integers, but some integers are not whole numbers. Okay? Then we get to our next category, which is the rational numbers. And the rational numbers are numbers that either repeat or end. So that could be things like -3.5 that ends, doesn't keep going, or 2.3 repeating, or 1, or just -2. Okay, so all integers are also rational numbers, but not all rational numbers are integers. Okay? But as long as it ends or repeats, it's a rational number. And then irrational numbers are kind of in a category of their own. Because irrational numbers, like we talked about, don't repeat and don't end. So that is things like pi, or if you just had like -2.34674, and it just keeps going on and on and on to the end of your calculator. Okay, those are examples of irrational numbers. They're in their own little category. Okay. All of these are real numbers. Natural numbers, whole numbers, and integers are all types of rational numbers. None of those are irrational numbers. So a whole number cannot be irrational, for instance. Okay? One of the things that you'll be asked to do today is to order different numbers on a number line. So there's kind of two main categories of question that you'll see today. One is to just identify numbers as being either irrational or rational and kind of figure out what category of number they fall into. And then the second is to order those numbers on a number line. So we'll look through an example of how to do that. Okay, so the first step when we're trying to order different numbers is to convert them all to decimals. That's the easiest type of number for most of us to work with. So I'll start just by converting these to decimals. So for instance, to convert A into a decimal, I just do 1 divided by 3. That gets me 0.3 repeating. So this is 0.3 repeating. And then I'll do the square root of 2 is 1.41421356. I don't need to write all of that out. I'm just going to write 1.414, and then I'll leave some little dots there so I know that it kept going even though it didn't repeat. And then I'll do -6 divided by 7, which gives me -0.857, and so on. -12 divided by 17. Again, it's a non-repeating, non-terminating number, -0.7059-ish. Next up, I've got negative square root of 3 divided by 2. So I'll hit my negative sign first, then my square root of 3, and then I'm going to divide by 2. You can do that all in one step if you'd like. So -0.866 and onwards. And then the last one is the cubed root of 8 divided by 2. So on my calculator, to do a cubed root, I hit the 3 first, then second to the power of button. That is my cubed root of 8, which is 2. And then if I divide by 2, I get 1. Okay, so let's put these on a number line. So the easiest one to plot is our whole number here, f. So I'm just going to plot that and label it. So I've got that one. 0.3 repeating. Because it's a positive number, it's going to fall somewhere between 0 and 1. 0.3 repeating. If I kind of break this up, I would have like 0.5 around there, so 0.3 might be in there somewhere. So A would be roughly there. 1.4 would be about halfway between 1 and 2, so it might be like there somewhere. Got that one. -0.8. So it's not quite to -1 yet. I might put it around there. -0.7 is going to be closer to 0 than -1. Okay. Remember, when it comes to negative numbers, the larger it seems, the more negative it is. So the further down the negative line it goes. So 0.7 might be there. And then E is -0.86. So 0.86 is a bigger number than 0.85, and so it's going to be further down the negative line. So E might be in there somewhere. Okay, this is what it would look like if it just told you to order the numbers. Now, if it told you to order only the irrational numbers, then you would cancel out any of the ones that are rational. So our rational numbers in this case is our whole number here. So that's rational. And our repeating number over here, 0.3 repeating, is also rational. All the rest do not end, they keep going, and they don't repeat. They're not repeating numbers. Okay, so all of these are irrational. Okay, one common mistake is to see a number like this that repeats, this 6 and 6. It doesn't count as a repeating number unless it keeps happening over and over and over again in the number. So if this is just 2 6s in a row and we don't keep seeing 0.866 over and over and over again, then it's not considered a repeating number. Okay, so that's why it's irrational. Okay, that's it for today's lesson. I will post your homework on Google Classroom.